Hello, I'm Philip Stoughton. I'm at SMTAi in Chicago, and I'm joined by Mike Conrad from Aqueous. Mike, great to see you again. Thanks for stopping by. You're presenting today, and your topic, I think, is SMT wars. Sounds very exciting. Tell me a bit about it.
Well, a couple of years ago, I received a phone call from a lawyer, and it sounds kind of counterintuitive, but it was actually a very exciting call because the lawyer started dropping words like ECM, electrochemical migration, and dendritic growth, and CAF, and fires, and it was just music to my ears. It was a very exciting set of words to come out of a lawyer, and they weren't talking about me. So, long story short, there was a lawsuit between a intellectual property owner and their contract manufacturer. And the issue was reliability with the parts that were being made to the specifications of the intellectual property holder by the contract manufacturer. And these parts that were being made were rather unusual. They were a radio sensor type assembly that would be buried in the ground a couple feet under the street at intersections all throughout North America. And because there's no natural power source in the ground, the parts would have a battery, and the battery would transmit a signal up to a receiver, a powered receiver on a nearby utility pole. And the batteries were supposed to last about 10 years, and the batteries lasted about 6 months. And that got the attention of both the contract manufacturer, the intellectual property holder, and their mutual customer, which were a bunch of municipalities all over North America.
Yeah, and a bunch of municipalities that didn't want to dig the streets up every 6 months, I guess. So your role in this became the expert witness role, or?
Yeah, I was hired as an expert witness. My focus is on contamination and failures associated with contamination, so electrochemical migration, CAF, things like that. So they hired me and other experts known to our industry to work this case, and we were representing the contract manufacturer. So I was privy to a lot of their emails back and forth between the intellectual property holder and the contract manufacturer, and the statement of work and the instructions to how to assemble the product. And really what happened was the contract manufacturer assembled the product exactly to the specifications of their customer, to the detriment of the product.
Right.
And several experts, both at the contract manufacturer and some of their other colleagues, were calling out issues with the way the products were being built, and were predicting the possibility of reliability issues. The problem behind the problem was the intellectual property holder was being funded by venture capitalists who had a schedule to keep, they had dollars to make, they had balance sheets to look at, and they were making decisions off the balance sheet and income statement rather than what was best for the product.
Yeah.
So they were pushing for production regardless of the complaints and the concerns that were being generated.
Okay. So the litigation was about, on behalf of the intellectual property owner, saying the contract manufacturer failed in the manufacturing, and the argument of the contract manufacturer was we made exactly to spec, and therefore we delivered exactly what was required. Expert witnesses on both sides?
That's right. There were expert witnesses on both sides. One to say that it was the contract manufacturer's problem, they should have stepped up and spoke more loudly. And on the side I was on, which was they were doing exactly what they were told to do, they gave them ample warnings, and everyone was chasing the bottom line.
Okay. And you were able to use the expertise you've gleaned from years in the cleaning industry to advise them on that. What was the outcome of the case?
The outcome is it eventually settled after several $1 million in attorney's fees on each side. Right. So, everybody won, nobody won. The attorneys won. The main findings, the takeaways, were that they were building this product, reflowing it with water-soluble solder paste, washing it in just water, which seems reasonable at first glance, and then they were soldering on this large device, this large through-hole device that had a lot of thermal mass to it, using no clean flux, They applied way too much flux because of the thermal mass aspect. They applied way too much flux. They didn't remove the flux, but they thought they would be okay. One of the so-called sins in the process was they should have used a chemical in their main wash, because there are two types of residues we're concerned about. One is polar, one is non-polar. One is soluble in water, one is not soluble in water. The flux that they were using was soluble in water, so that was good. But all the other, what I call usual suspect contaminants, from board fabrication to component fab to humans touching it, many of those didn't subscribe to the water-soluble army. They are non-polar. They're not going to come off in water. So those were allowed to be on the parts. Then too much flux, unactivated flux, so it was conductive and corrosive. But they thought everything would be okay because they were going to pot this in silicone. And their idea for potting it in silicone was to keep all the nasty things outside from coming inside. What they really did is they just trapped the sins of the process inside. Yeah. So there was moisture, they didn't bake out, there was multi-layer board, no bake out process, no first in, first out inventory, no dry boxes to store the bare laminate material in. Then all these contaminants allowed to accumulate onto the board, not removed efficiently or thoroughly, and then potted and put into the ground. So the board suffered from dendritic growth, they suffered from calf, and a few other contamination issues, which caused the batteries to drain. Not a dead short, that would have been easy to find and test. The batteries drained because there was too much conductivity on the board. Yeah. And the batteries, which were supposed to last 10 years, lasted 6 months. Yeah.
Well, that's the issue, isn't it? It's when you've got an issue that you can't see at the end of the product manufacturing process, and it's going to arise somewhere in life. And, 5% success rate in battery life is not a good thing. So the moral of the story, when I look at people that I've worked with a few consultants that place contract manufacturing, and they always say you don't always get what you order, you get what you measure. Is there a measurement issue? Is there a process issue where they needed to measure differently, or was the problem in the spec at the very beginning?
Everything could have been salvaged with one simple process. I'd love to say cleaning would have solved their entire process, although it wouldn't. It would have solved some of it. A simple bake-out process actually would have solved it, because it takes three components to get electrochemical migration. One is electrical current, which obviously they have. One is conductive corrosive residues, which are flux and other usual suspects. And the other is moisture. Yeah. And if they just removed the moisture and then potted it, then even though they had some contamination, the fact that it was potted would have severely delayed the amount of moisture that would have eventually permeated through even silicone, and the parts would have lasted much closer to their 10-year target life. Cleaning and baking would have been the ultimate solution, but they could have just baked prior to potting. So the takeaway, as I see it, is something I've learned over 25 years in business. Sometimes the word no is much more profitable than the word yes. And we're all trained to say yes. We don't want to tell our customers no, because our customers pay us. Yet they weren't doing the customer any favor by saying yes when they should have said no, and they certainly weren't doing themselves any favors. They did me a favor, because me and a lot of other people profited from this as expert witnesses, but it really comes down to sometimes no is the best answer.
Yeah, and the other people that clearly profited, as always, are the lawyers.
Of course.
Last question, do you think there is a lack of that cleaning expertise within not just the CEMs or the contract manufacturers, but also within the OEMs or the intellectual property owners that are placing the business?
Yeah, absolutely, Phil. That's why we produce workshops all over the world, because cleaning was a mainstream process prior to the mid-90s, and then 1989, the Montreal Protocol, all the solvents went away, no clean came out as a result of that, and the industry, for the most part, the commercial industry certainly, not so much military and medical, but the commercial industry, which is the majority of the electronics today, stopped cleaning. They went to no clean. And when they got rid of their vapor degreasers and their solvents, they also got rid of the expertise and the knowledge. So we see people coming back to cleaning now, because it's a relevant topic again because of miniaturization and other things, without the knowledge. So we have people either with zero knowledge on cleaning, and they have this dumbfounded look, like the jar says no clean, almost like an instruction, almost like don't clean. And we're talking about cleaning, no clean. Well, no clean's inaptly named. It should be low residue. It shouldn't be no clean. But anyway, it is no clean. So they either have absolutely no knowledge of why we're cleaning and no clean, it doesn't make sense, or they have obsolete knowledge. So the first thing they do is they go out looking for pails of trichloroethane and an old vapor degreaser. So there is a knowledge gap when it comes to cleaning as associated with reliability.
Yeah. Oh, well, for me, the moral would be get as much information as you can and hire an expert before the lawyers do. That's the last point you want to hear, that there's an expert working for you.
That's right. Someone's going to pay us, right? So either this much money to get it done right, or this much money to do it over. And it's amazing to me how many, even us in our industry, in our business specifically, we've experienced this. Sometimes we don't have time to do it right, but we always find time to do it over.
Which is crazy. Thanks, Mike. I'm sure it'll be an interesting presentation this afternoon, and I know you're going to get lots of questions afterwards. Thank you very much.
Thanks, Phil.